Hello, Coach Holmes here, and today we're going to be talking about parallelograms and some of the different properties for it. Now, in the last unit, we actually talked about polygons and the number of angles it has. While this particular unit is basically focused on quadrilaterals, but in this section, in this unit, in this notes, we're going to be talking about parallelograms and the different properties that it has. Now, there's quite a bit of properties, so there's a lot of definitions, a lot of theorems that we're going to have to write down. But for one, we got to be able to know what a parallelogram is. And we've seen them before, so we probably know the definition already. But just to be clear, a parallelogram is a quadrilateral where both pairs of sides are parallel. Okay? Hence the name parallelogram. So basically what it looks like, I'll draw it up here. Is that both opposite sides are parallel to each other. Not just one pair, but both pairs. Both pairs of opposite sides. They are parallel to each other. That's what they are. Okay? And there's a lot of different properties and a lot of different things that we can actually say about parallelograms. For one, something to do with opposite sides. Opposite sides, which by the way, this all refers to parallelogram, okay? This whole theorem states about parallelograms. So for opposite sides of a parallelogram, opposite sides are congruent, no matter what. So anytime we have a parallelogram right here, let me draw a better one. There we go. So no matter what, the opposite sides for a parallelogram are going to be congruent to each other. That's the important thing to remember. Opposite sides are congruent. Now, what about opposite angles? Well, opposite angles are congruent. So, there we go. So if I look at opposite angles, they're going to be congruent as well. Okay? That's another important thing. Opposite angles are going to be congruent. Now, consecutive angle theorem. So what do we mean by consecutive? Well, we mean back to back, all right? Now, let me state what the fact is, what the theorem says. Consecutive angles are supplementary. So that means if I look at this, not only is A supplementary to B, but A is supplementary to D as well. So any type of consecutive angles, which we mean back to back, they're going to be supplementary to each other. Okay? So really and truly, if you have to really think about it, if the angles of a parallelogram is not congruent, they're supplementary. Okay? So for example, A and B, angle A, angle B is 180, as well as angle A and angle D is supplementary. And we can include C for B and D. We can include that for both. But I'm not going to write that down because I want to clarify that it's not just these two that are supplementary, both the ones in the bottom and the ones in the top. Okay? That's what I'm going to be able to clarify. Now, right angle theorem. So, if a parallelogram has one right angle, let me rewrite the one, well, at least the word, has one right angle. I'm sorry, guys. Then it has all four right angles. Okay? So even if it just has just one right angle, all four angles are going to be right angles. So a good perfect example of this would be like a square or a rectangle. Those are actually parallelograms as well. Because if you really think about it, rectangle is going to have opposite sides are congruent. That fits the parallelogram. Square is going to have all four equal sides, so we know opposite sides are congruent. And there's a lot of different things. All of them have right angles, so really and truly, however you want to look at it, rectangles and squares are parallelograms as well. Okay? And this theorem actually clarifies and pretty much even gives it more proof that it's as well as a parallelogram. Now, next we have diagonal theorems. The diagonal line of a parallelogram bisect each other. So, what does that mean exactly? Well, if I draw a little parallelogram, here's one diagonal line, and here's the second. And they actually bisect or cut in half to each other. All right? So while one side may be longer than the other, but they both bisect each other. Okay? That's a very important quality and a very important key. They may have different size as far as diagonal lines, but they still bisect each other. Now, congruent triangle theorem. Each diagonal of a parallelogram each diagonal of a parallelogram separates into two congruent triangles. So, what does that mean? Well, even if I just have one diagonal line, like this, these two triangles are actually congruent to each other. It doesn't matter which one I look at, they're both going to be congruent to each other. Okay? So, in hindsight, I have two congruent triangles. And I can do the same thing for a different diagonal, and it still be the case. That's what we're actually seeing. So basically what I mean by that, so if I just get rid of this line, and make a new complete diagonal line, those two triangles are congruent as well. So it doesn't matter which diagonal line we use, they're both going to be congruent. Next, I want to find three different things. And I forgot to write this down. We want to find the following. We want to find the following. we want to find angles YEN, angle YPE, and I want to find the value of Y. I want to find those three things right there. So first off, let's look at, I want to use a different color. Let's look at YEN. So I'm looking for this particular angle right here. I'm looking for that angle. Well, let's think about this for a minute. If we remember transversal lines, we know that if the lines are parallel to each other, then alternate interior angles are congruent to each other. So by knowing that fact, we know that YEN is 40 degrees. Because they're alternate interior angles. Now we typically see it like this, but it's the same as true if it's like this. Alright? Now we want to find YPE. So we want to find this angle right here. Well, remember one of our consecutive angles theorem? It basically tells us that consecutive angles are supplementary. So if I look at this whole thing right here, 40 plus 18, that gives me 58. Well, all I gotta do now is subtract 158 from 80 to get me angles YPE. So, if I subtract the difference, give me a calculator. $122. So YPE is 122 degrees. And next we want to be able to find Y. And I want to use a different color. I want to be able to find Y. Well, I know that opposite sides are congruent to each other. So I can set these two equal to each other. Next, I want to divide by 3 to both sides. So Y equals 6. Alright, and we were able to do this because we know certain facts about parallelograms. For one, we know opposite sides are parallel. 2, we know that opposite angles, we know opposite angles are congruent, but that didn't help us find this. What helped us find this was consecutive angles being supplementary. And lastly, we know that opposite sides are congruent. So as long as we know these facts or these theorems of parallelograms, we're going to be in good shape. Thank you and have a good day.